Okay, so we're going to cover metric conversions. So the first thing about the metric system, here are the units that we use for each particular thing that we can measure. So for length, we measure in meters for the metric system, volume liters, mass grams, time seconds, and then temperature Celsius. There's a second set of units that are similar to the metric units. There's some differences. What they're called SI units. It's like the international system. And so you can see there's some differences. Primarily, though, you'll see us use either of these, but it's good to know the differences between the two. All right, so if we go back, what we were looking at is what we call the base units, right? And so we can use these prefixes to help us determine the size or the amount of each unit. And so the way you can remember this is the Grand Master King Henry died by drinking chocolate milk. So down here, underneath people's feet. And what that refers to is the abbreviation. It's like a mnemonic, the abbreviation for each of the prefixes. So like, for example, when people run and they run long distances, we might say it's a kilometer. And so a kilometer is this prefix, kilo, and then you add the base unit. So it has two parts. It has a prefix and then it has a base unit. And so this would be kilometer. And so 1 kilometer equals 1,000 meters, right? So this is the base unit here. So from here to here is 10 to the 3. Okay? All right. So in 1 kilometer, there's 10 to the 3 meters. So this is the amount of the base unit. So if you have a 1 millimeter, so here's milli, the prefix. So 1 millimeter equals 10 to the minus 3 meters. Okay. Okay, so we have prefixes, and then they always go with the base unit. And remember, there's different base units depending on what you're measuring, right? And just to remind you, those base units are found here, right? Depending on what you're measuring. Okay, so our goal today, after learning all this, is to ultimately be able to convert between these units. And so to do that, we have to use what's called a conversion factor. And so let me talk about, we kind of been talking about it. So let's say we want to convert, let's see, a centimeter, or let's do it to the base unit first. So let's say we want to go, let's say a centimeter. So we want to convert meter to centimeter. And centimeter would be cm, right? Okay. So basically, I want to know, I want to know what a conversion factor, and a conversion factor is just merely in 1 meter, how many centimeters are there? So in 1 meter, how many centimeters are there? And so you can do it either way. Like you can ask in 1 centimeter, how many meters are there? So what I would do is I would find centimeter, and it tells you numbers of base units. So our base unit is meter, right, in this case? So this would be 10 to the negative 2 meters. So 1 centimeter equals 10 to the negative 2 meters. And so this is called, what I just came up with is called a conversion factor. All right. Okay. So let's do another one, just for more clarification. So let's say we have, we want to convert between liters and say kiloliters. So we want to convert between those. And so in this case, let's identify. So liters doesn't have a prefix, so therefore it's a base unit. So here's liters. And then kiloliters is here. So here it shows you that 1 kiloliter equals 10 to the third base units, which is liters. So we now know that 1 liter equals 1,000. Or let's use 10 to the third kiloliters. All right. Okay, so we're going to use that and solve some problems together with this. So here we have 200 kilometers to meters. So what I'm going to do is actually go back. Now, you're going to have to memorize this. You don't, but you would have to memorize, or you would have to make sure you know how to use this, because it's not going to be provided for you. So that's why the Grandmaster, King Henry Died by Drinking Chocolate Milk Underneath People's Feet, is a good way to kind of remember this. But if we did the first problem together, excuse me, so 200 kilometers to meters. So the first thing I do is we figure out, so we're going from meters to kilometers, right? And from here we can figure out that 1 kilometer equals 10 to the third meters. So our conversion factor is 1 kilometer equals 10 to the third meters. And so now we're going to do something called dimensional analysis. And what is dimensional analysis? It's let me show you. So let me give you an example. So we're starting with, I think we were starting with 200 meters, okay? Then we're going to multiply it by a fraction. The numerator and the denominator will come from my conversion factor. Remember, this is what's called our conversion factor. And so ultimately, the way we look at this is we're going to ultimately put 10 to the third meters on the bottom and 1 kilometer on the top. How do I know to do that? Well, we always want the same units to be across from each other so we can cross cancel. All right. If I flip the kilometers below, I wouldn't be able to cross cancel, because in order to cross cancel, they need to be the same. For example, like if I had a fraction, right, 1/2 times 2 over 8, like I could cross cancel those two. So in the same way, that's how we cross cancel our units. All right. So once I'm done with that, I'm just going to, so 200 on top, right? 200 times 1 is 200 over 10 to the third. Now, anytime you're over 10 to the third, that's called like a reciprocal. And so really what that is 200 times 10 to the negative 3. And then we would go ahead and solve this. So if I solve this, and remember, look, what units are remaining is kilometers. So this would be kilometers. So this would come out to, if I converted this into standard form, this would be 0.2 kilometers. So that's how I would solve it. So just to recap, I did 1, I always figure out the conversion factor, right? And then 2, I use what's called dimensional analysis so that my units cancel out. And then I solve, so I multiply the top, and then divide by the bottom, and then figure out my answer. All right? Let's try another problem. So we're going to go 310 milligrams to grams. All right. So, let me go back. So 310, our problem is 310 grams to milligrams, right? Okay, so now we got to figure out what's the conversion factor between grams and milligrams. So if I find the milli is right here, grams is the base unit, so that means that 1 milligram equals 10 to the minus 3 grams. Okay. All right, so then I'm going to take my 300, so that's my conversion factor. That gets me to grams. So I take my 310 grams, and then I'm going to convert that to milligrams. I use this, now I'm going to put the 10 to the negative 3 grams on the bottom, and then 1 milligram on top, right? Why did I choose that? Because that allows me to cross-cancel my grams. Then what I'm going to do is take 310 over 10 to the negative 3 milligrams. That's equivalent to 310 times 10 to the third. You take the reciprocal, you just kind of flip that sign on your exponent. So that's milligrams. So this is 10 to the third. So if I convert this into standard form, it'll just be 310,000 milligrams. Now, usually if you're gonna be greater than 10 to the third, it's better to keep it in scientific notation. So this would be 3.1 times 10 to the 5th milligrams. Okay. All right. Let's do one more problem. So let's try this one. So actually, let's try this one. We'll take the hardest one. So 2,000 micrograms to kilograms. So this is actually a two-step problem. And so let's talk about it. So 2,000 micrograms going to kilograms. This one's interesting because you're going from here, right, micrograms to kilograms. And so I would suggest maybe doing like a stop at the base unit and then continuing on. So let me talk about, so you'll need two conversion factors. So the relationship between microgram and the base unit, which is grams, is that there's 1 microgram for 10 to the negative 6 grams, right? So for every 1 microgram, it's going to be 10 to the negative 6 grams. And then to talk about the second relationship between kilograms and grams, it's 1 kilogram is equal to 10 to the third grams. So 1 kilogram is equal to 10 to the third grams. Now you could combine these if you wanted to, but you could actually make this a two-step process. We want to go from microgram to kilogram. So I'm going to start with 2,000 micrograms, right? And if you think about it, I have to use this conversion factor first. The reason why is that microgram is in this. So I'm going to put 1 microgram on the bottom and then 10 to the negative 6 grams up top. This cancel out, but if I stopped here, I would have grams left over, but I don't want grams, I want kilograms, right? And so I have to use my second conversion factor, so you can do this again. You can just make another one. So 10 to the third grams to 1 kilogram. Now if I cross cancel, again, what are my remaining units? It's kilograms, which is what I want. So let's do this. If I multiply this all out, I'll have 2,000 times 10 to the negative 6 all over 10 to the third. What would that be? That would be equal to 2,000 times 10 to the negative 6 times 10 to the negative third. Oh, yes, right? Because remember, if it's divided by, we're just going to take it's the reciprocal or the negative, the opposite sign exponent. So 10 to the negative 6, 10 to the negative 3. Remember, when you multiply exponents, you just add them together. So this would be equal to 2,000 times 10 to the negative 9, which ultimately we're going to keep in scientific notation, but 2,000 isn't a good, is not the correct scientific notation. So ultimately this becomes 2 times 10 to the negative 6. Okay, so this is an example of where you had to take 2 steps to get where you needed to. There's plenty of practice as well for you to work on the last slide.